First of all, Assalamu alaikum. I'm glad to be here for the second time with the team, Abdul Qadir and the others. Okay. So first of all, this talk is about asynchronous JavaScript. We'll be talking a little bit about asynchronous JavaScript.
Can you please talk a little bit louder?
Louder? Okay, no problem. So this talk will be about asynchronous JavaScript. Okay. So first of all, this is the title. We will talk a little bit about me, blah blah, and the story. So I'm Ismail Hamadi, or Hamza for short. People know me Hamza. Okay. This is my Twitter handler. This is my email. This is me at 3 a.m. Okay. Now with the gear shave. Okay. So the first question before getting started, I just would like to know who is a JavaScript developer, or in first place, who is a developer in first place? Me, I'm not a developer. In the first place, who is a developer? Who is a web developer? Don't be shy. Okay, okay. Who is a JavaScript developer? Great. Yeah. Okay, so hopefully this talk will be great for you. So I have this is my first time with this was my feeling the first time I get to deal with asynchronous code. You know, usually you have synchronous code. You have the first instruction, then the second instruction, then the rest of the code. And you would expect the first instruction will get executed, then the second one, etc. But unfortunately, with asynchronous code, it doesn't work like that. Okay? So this was my feeling first time dealing with asynchronous JavaScript. I can't lie to, I would like not to lie to you, but it's still till today, in some aspect, not in the whole, but in some aspects, because it's a very interesting and very complicated topic. Okay? So first of all, let's start with the agenda or the content table. We'll talk a little bit about asynchronous code. What is asynchronous code? What is synchronous code? Okay. Then we will talk a little bit about concurrent versus parallel code. So it's a big confusion right here. What is the difference between concurrent and parallel code? Then we will talk about callbacks. Who knows about callbacks? Callbacks. Great, great. Then we will talk a little bit about thanks. Anyone heard about thanks? Great. Then we will talk a little bit about promises, what they are and
Hamza, could you talk a little bit louder? It's almost impossible to hear from here. Yeah.
Can you?
Yeah, yes, now I can.
You can. Okay, then we'll talk a little bit about generators. Okay? Then we'll talk a little bit about, not talk, but just mention some other cool and exciting features or concepts that are rising nowadays and in the future. Okay? So the first thing is asynchronous code. What is asynchronous code? Okay? Can anybody explain to us what is asynchronous code? Can anybody here in the room explain what is asynchronous code? Callbacks. What is callback first? Can anybody explain to us what is asynchronous code in simple terms? Let's assume I'm beginner or I don't know what is asynchronous code. Please go ahead.
Callbacks wait for permission from another part of the code to continue its execution.
Yeah, to put it simple, it's a part of the code that is dependent on something else. It's like a trigger in databases. Okay, so you have a part of the code who is waiting for another part to give it permission or to give it an event. Okay, to continue. Just simple code is as I have here. Simple. Let me open up the terminal to look like a geek or a professional. Okay, It will just. Can you all see this snippet of code? This is asynchronous code. What do we have in the second line? In the first line, it's a comment, obviously a comment. In the second line, what do we have? We have. What do we have? In the second line, we have console.log. We are logging to the console something. Obviously, it's like printing something to the console. Okay, it's like the printf in C or system print out, I think, in Java, etc. We have here this part, the second part, here starting from this line, starting from line 3. What do we have? We have set timeout. What does set timeout for the JavaScript developers? Set timeout.
Waits for 10 seconds. This
Wait.
is 10 seconds, but then
Yeah, it waits for a period or for a delay or for a period of time. In this case, or in this example, I have 10. 10 refers to 10 milliseconds. This number is in milliseconds. Okay, meaning 0.001. Okay, second. Okay, what I have here, I have set timeout. Then inside this set timeout, I have another message logged to the console. But this message is logged straight to the console, whereas this message must wait 10 milliseconds to get executed or to be logged to the console. And also I have this one, the third, or the code in the line 6. In your opinion, can you give me the execution of these instructions? In the first, if I print these, or if I execute this code in the console, what would be the result? This will be the first one in the log to the console, getting data from the server. Then, what's the second? What is the second message log to the console?
6.
Is it 6 or is it 4?
it's done.
4.
Who says 4 or says 6? Who
6.
says 4? 4. No 4 here? Okay. Actually, it's 6, then 4. Why? Because we have a timer here waiting for 10 milliseconds. And fortunately enough, I have in my editor, I can execute JavaScript. Okay, so if you can see here, I have a console. Okay. Here above, I have my JavaScript code, and here I have the execution or the result of this code. I have in the first line getting data from the server, obviously. In the second, I have done. Okay. In the third, we have your data is blah blah. Okay, yeah. Because we have a timer. This timer will play the role of asynchronous thing. This code is not executed directly or straightforward. This code will wait for 10 milliseconds. Even if I try to, instead of 10 milliseconds, I will put 0 millisecond. What does it mean, 0 millisecond? It means it will wait or will not wait? In your opinion? Wait. The other guys. So if it will wait, what we will get to the console, log to the console? What we will get in the console for this case? Do we get the same output or another output? Who says the same output? Same output, yeah. The rest, we will get a different output.
Different output.
Yeah.
It waits for about 4 milliseconds.
Unfortunately, it's the same. We humans understand it like this. Why? Why? Because here, if I execute it again, I save my page, then execute it again. I getting data from server, then done. Your data is done. Pretty much, I get the same output. Why? Because this timer will wait for this amount of time. In this case, it's 0 millisecond. Then once 0 millisecond is done or is fulfilled, it will be queued to a queue. So if I have For example, if I use, just allow me to use, let's say, for example, I used here set timeout. For example, I have set time out function, and here it's called the main queue. Or can anybody give us the name of this queue? What's it called? Louder, louder. Yeah, it's called the event loop. Yeah, excellent. The event loop. Pretty much it's simple queue with all the processes queued or stuck like this. For example, this P1, and P2, then P3, and the rest of the processes. For our case, we have set timeout. That code or that function, this function, or callback, this one, will not get executed immediately. It will be stocked or queued in this queue. Then what we have 0 millisecond, okay? Then it will be queued in this part. Once it reaches the main queue or the event loop, we will be done with these two instructions, okay? This is why we get this, the first one, getting data from the server, then we get done, then we get this, okay? This is the asynchronous code in its simple way. This is the simple way that you can get, okay? And this timeout could be anything. Could be, for example, a file upload or getting data from the server, okay?
What if you have a console in 7 type?
In 7, like
Any console,
if I have here,
what do you do to order?
in your opinion, what's the order? We will get getting data from the server, then geeks. Then what is the second message to the console? We will have this one, the first one. Then done. Then another. Then we will get data from. Yes. Let's try it. Okay. Why? Because once this, let's for example call this callback. Let's give a name to this callback. Let's call it.
Does event loop works after all the synchronous calls are done?
Sorry.
The event loop
Yeah.
will work after all the synchronous calls are done.
Yeah. All this. Yeah. We have the event loop is very simple queue, very simple queue with the processes in it. Like for example here we have the processes P1, then P2, then P3. P1 can be one instruction, can be a function, can be a block of instruction. It doesn't matter. Okay. We have P1. In this case, we can consider this one as P1. Then what we have? We have this set timeout. Okay. This timeout is not queued in the event loop. It's queued here. Okay? It's added here in another queue, not in the same queue. Then what we will stock in the main queue or in the event loop queue, we will stock this one. Done. Then another. So we will have this. Let's for example, let's say this is 2, this is 6, 7. Then let's assume this is 5, for example. We will get this 2, then 6, then 7, and we have here 5. 5 doesn't wait for any millisecond, but it has to wait for the main queue. Okay? So we have the main queue here. The main queue we have in the main queue, we have the code in the line 2, 6, and 7. So they will get executed before this callback. Even we have a timer for 0 millisecond. Okay? And in let's not get it confused, because even with this timer, if for example I have for example, let's say 5 timers. every, for example, let's say 10 milliseconds. Let's say, for example, I want in every 10 milliseconds call a timer. Even for this case, I have 5. For example, let's say 5 times. Yes. Let's say, for example, 2, 3, 4, 5. Okay? If this timer we consume more than the period to get to the second one will get cancelled. Okay? This is JavaScript. Welcome to JavaScript. Okay? Let's move to the second example. This is the notoriously known XHR or HTTP XML request. Okay? Basically for getting data from the server. Okay? So we have the XHR object equal new blah blah blah. The rest of the code is obvious. Okay? We have here what we call this. I assume all of you is JavaScript ninja or developer or whatever. What is this? Yeah, it's property after all, but what it does? What it does? Yeah, it's no. I mean it's called, obviously it's called callback. Well, because we have this equal function. It's a callback, and what it's doing here? On ready state change. What we call this? When we have, excellent. When we have on something, it means it's an event. Okay? When we have on something, on X, on Z, on something, it means that is an event. Okay? So what we are doing here, we are waiting for this XHR, we are waiting for the ready state change event. Okay? There is an event called ready state change. When the state change, this event will be fired. Okay? So we have on ready state change, execute this function. Okay? Then inside this function, what we have? We have if this ready state change, this ready state equal 4, or this state equal 200. 4 stands for what in this case, or in our example? This 4 stands for what? Let's assume you are in interview, in JavaScript interview. Okay? Yeah, it stands for what? This 4. In JavaScript interviews, you're not allowed to use jQuery or any other. Okay? This 4 stands for what?
Example, file process. For example, 1, 2, 3, 4.
Yeah.
Every number indicate the situation of the process.
Yeah, but 4 stands for what? No. No opinion. Okay. This 4 stands for completion. It means that the request or the server completed our request and sent it back the response. Okay? Then we have also this status equal to 100. This 200 stands for what? For? Great. For success. We have 404 or 404 for not found. We have also 500 for the beautiful internal error, etc. Okay? So basically, in this condition, we are trying to spot or to get only when we get the final result from the server. Okay? So we are making sure our request is completed or the response is completed. Then we get 200 status, which means that we get back our data successfully. Then here, I'm just logging out to the console, the response. Okay? And then I have also opened the request. Okay? This is a simple case of asynchronous code.
What does this refer to as this if?
This.
XHR or
Excellent. In your opinion?
It should be XHR.
I don't know. I'm asking you.
Because
This keyword refers to what? In this context? This
Human resource review.
refers to what? This? It refers to the XHR object, this one. Okay? Because here we are creating an instance of XHR object. Okay? So this is XHR, is an instance. Whenever you call this will refer to the environment of on ready state change. And on ready state change is appended to XHR. So this will refer to this XHR.
I have access looking from the main scope.
From the main scope,
Yeah. Main scope.
from the main scope, you will say XHR.ready state change.
But can I access anything in this statement from
Yeah. The global scope. You're talking about the global. Yeah, of course. You can access. For example, if I have here, for example, let's say. For example, you can access this variable inside here, okay? You can, for example, check against it or use it whatever you want. We have a small distinction here. If you try to use this keyword inside this callback, what do we get? This, for example, if I try to log this here, what is the value of this? Yeah, global. What is referring to? Yeah, window, or let's say window or document, okay? One of, but here, this refers to, that's it. If for example, I have here, for example, let's say I have here, this is very important notice here. For example, let's say I have a function. Yeah, please. Okay, let's say, for example, let's say I have two global variables. Let's say, yeah, I have place. Okay. This inside this function refers to what? If I say this, inside the random function, this refers to what? Global. Yeah, global, to the window or the environment, okay? In my case, it's the Node.js environment because I'm executing JavaScript in Node.js environment, okay? So this refers to this one, the global scope or the window scope or the Node.js environment. But if I try, for example, let's say here, I try, for example, console.log this dot place, okay? This is the same thing as, do you agree with me? This is the same thing. We have this dot place or place, okay? It's a shorthand of this dot place, okay? Whereas, if I try, for example, let's try, instead of executing random here, random, okay? I will try to take this random from here and put it here. In your opinion, do we get any problem here? What is the problem here? What is the problem here? Do you see the problem first? For me, there is no problem. Do you see the problem? Do you spot the problem? What is the problem?
I'm trying to find script
Excellent. Simply because we have different context, okay? Because this inside this block is not the same this outside the block, okay? For the first time, it seems like it's the same because this the same. In this case, do you have a question? No question. Okay. In this case, what do we use? In this case, to solve the problem, what do we use generally? Yeah, call or bind. Yeah, excellent. So we use call or bind. Why do we use call or bind? Yeah, great. To set the context or to change the context. Okay, great. So this is a side note. This is very important note here. So we should be aware. We have to be aware of the context. Okay, because executing this here, we will not get any problem. But executing the random inside this XHR, we will get a lot of trouble. Believe me, especially if you're hired in in a company. Okay, so this is the first one, the first case. This is the asynchronous code. Okay, we didn't get to the callbacks and the rest of the members. Great. So this is the first thing, asynchronous code. We have also okay. We have also concurrent with parallel code. Let me just ask a question. What's the difference between parallel code and concurrent code? What's the difference? What is the difference between the two? When we say a concurrent code and a parallel code?
Number of threads. Concurrent can do its job in one thread, but parallel code needs multiple threads for code running parallel to each other.
This threads mean you're talking about parallel code or the concurrent code?
The parallel code needs multiple threads.
Yeah?
The concurrent code can, well, one thread is okay, they just yield to each other on a single thread.
Yeah. This is why we have the concurrent. The concurrent here means the concurrent here because generally when we, for example, if I the first example when I try to log out to the console, the instruction or the messages to the console, we get them straight. So we have here. I don't have. Okay. I have here. For example, let's say I have. For example, this one. I have. In my case, I have two tasks, or we can consider them as processes. Okay. I have two processes. We have task 1 and task 2. Okay. It doesn't matter. We have two jobs or two tasks. Okay. In the parallel code, as he said, we have different threads or different, let's say, part manipulating or dealing with that part. For example, if I use threads or in the parallel coding, I have this task running in one thread and this task running in another thread. Okay? This is in the parallel coding. But in the concurrent code, we have what we call time frame. Okay? We have time frame. Okay? In this case, task 1 has, let's say, 4 instructions. Okay? Whereas task 2 have only 3 instructions. Okay? So we get this. Let's say, for example, E11, E12, etc. Okay? And to put it simple, I use this simple animation. That took me an hour and a half. Okay? So if I give you this time frame as a whole, you will see it as if it's executing in parallel. This is why we say concurrent. Okay? But at any given precise moment, for example, let's say I would like to know at the moment, for example, 0.001 second, for example, let's say. At any given precise moment, only and only one process is executed. Okay? This is what we call concurrent. Okay? Okay, so we have two. We have the parallel code executing in different threads. And even with the threads, we have a lot of problems. Okay, for example, how to synchronize between the two. If, for example, let's say this thread needs to communicate with the other thread. Okay, how to guarantee the communication between the two. Okay, there's a lot of, okay, but let's keep it simple. Okay, so this is the concurrent code. Okay, so the concurrent code we have, for example, instruction from this process and the instruction from this process, one by one, until the end. Okay, and as we said, as we are seeing here, at the end we had this main time frame. Okay, this is the concurrent code. Okay, in JavaScript, we only have concurrent code. Actually, recently we've had a new technology called web workers. I don't know if you've heard about it. Web workers. Web workers. It's basically something like threads. Okay, so we have a bunch or a chunk of code executed in separate environment or in a separate worker. Okay? So this is the concurrent parallel code. We arrive to the callbacks. The one that I love the most. What is a callback? We discussed what's callback. So, to put it simple, a function that is passed to another function. Every function that is passed to another function is called a callback. Okay? It doesn't have to wait for 10 seconds or for any amount of time. Okay? Every function that is passed to another function is called a callback. Okay? It will call it in the future. Maybe in the future, maybe right away. Okay? Right now. Okay? An example, let's just go straight to the examples. Yeah, one of the simple examples about callbacks is for example, the buttons. Let's assume I have an interface with HTML elements in it, okay? I have here login button, okay? So I'm referencing an element with a login ID, okay? Then what I have here, login, I'm adding event listener, okay? So I'm adding simple event, okay? Click, the type of the event is click. And once this button or this element is clicked, okay, this function is executed, okay? So if I come here, to put it simple, let me just grab it here. Okay, no. It's not, let's say for example I have this page, okay? Let's say for example just I want to add a button, okay, with the ID login, okay? Let's say login. You want to log into your account, okay? Okay, so we've got this nice, do you see it? This nice login button, okay? We have this, okay. So we have this login in our HTML page, okay? So I'm adding this event listener. Let's come back here. Okay, I have this code that I just copied from the snippet of code. What I'm doing here, the first instruction is referencing the element, okay, referencing this login button, okay? And this code is executed once this code is executed once the click is performed, okay? This one is called a callback. Why? Because it's a function passed to another function. If I can simplify this example, simplification would be something like this. If I come here, button click, or I call it function button click, okay? Then I will grab all this code, okay? I will put it here. Then what I put here now? Just okay? So it would be something like this. Okay? So instead of putting the anonymous callback here, I have a named function called button click, okay? So, and once the click event is fired, this callback is called or executed, okay? So this is called callback. Why? Because we have a function that is passed to another function. Because this one, even this one, add event listener, is a function, okay? Add event listener is a function. So we are passing a function to another function. And this makes button click a callback. Okay? If we use button click outside this environment or outside this condition, it won't be called callback. It would be called just a function, simple function. Okay? So this is callback. Okay? This is the callback. So if I come back here, let's just put it simple here. Oops. Okay. So I have this. Okay. You will see I will get the same result. Okay. To the console, I'm logging to the console, login button clicked, then this is the event. Okay. So I'm logging out also the event that was emitted. Okay. This is why I'm having this instruction. Okay. So once I click, I will get button click. I will execute button click. And what I have in button click, I will log to the console, login button clicked, then I will log also the entire object or the E object. This E object refers to the event itself. Okay. Is it a click event? Is it mouse down? Is it mouse up? Etc. Okay. This is a simple example of callback also. Okay. Great. To make it a little bit something like what do we have in the real world? Because in the real world we don't have only buttons. We have also inputs. Okay. For example, a text area or something, some place where we can type. If, for example, I add here, I have, for example, here input type equal text. Let's call it username, for example, for instance. Okay. Let's give it an ID of username. Okay. Then we're adding this. Okay. 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 So I have this one. So instead of having only one button, what do I have here now? I have this input of type text and also this button. Okay. I would like, if I type something here, this button will take this value and print it to the console. Okay. So my code will be something like this. So we have this callback. So we'll make small changes. Okay. Button click. What I have to do here in order to get the value of that input?
Should use a key press or something?
Do I have to use key press? I would like to get the value of that input once I click on login. Yeah, that's it. I will get the element. I will get a reference to that element. And once I click on the button, I will try to get the value of the element. Okay? So it will be something like this. Once I click add event listener, once it's clicked, the button click is executed. So here inside this code, I will reference input element. Okay? I will reference the input element, let's say input. Okay? Var input equals the same thing as we have here. Only here, what do we have here? Instead of login, okay, then okay, let's add this. Okay, so now if I click on this login button, I will get nothing logged to the console. Why? Because I haven't typed anything into this input box. What I'm getting here? Yeah, what is called this? It's not in inner HTML. This is the element itself. In order to get what I want to get the value. So I will call, okay, so the element dot value. If I come back here, okay, oops. Let's try to execute this code again. Okay. So now, if I click here, why I get these two lines? Because I have two events registered to the same elements. Okay. We have the previous event and this one. If I type something here, for example, let's say my email address. If I press login, okay, clear enough, I get this value. Okay. Okay, I get this value. Why? Because if I click here, it's here. Log in the value of the input. Okay. But if I try, for example, let's try here, console.log, your username is, then let's say, for example, I want to username. User name var user. Okay. If I'm trying to access the value of username, what I get here? In this case, what do I get here? If I try to access the value of username,
Undefined.
so I get undefined. Why I get undefined? Because the event is not even fired. Because it's an asynchronous code. This one may execute or may run, as it may never run. Okay? Because it depends. If I don't click on the button, the value of input will never be different than undefined. Okay? So this is the kind of callback that we use. We have what we call here callback. Okay? I can even instead of calling it button click, I call it callback. Okay? And here I will rename this to call back. Okay? And to simplify it furthermore, as we humans, once I click on login, execute this callback. Okay? So it's like once I click on this element, execute that code. Okay? This is an event. Okay? It's like when it's 10 p.m., go to bed or something. Okay? So it's an event based. Okay? This is an event. And all events are asynchronous. You don't know when you get the response. It may be just 2 seconds later, maybe 10 milliseconds, maybe 10 hours, maybe never. Okay? This is what we call callback. This is the first example. Okay? This is the first example of callbacks with events. We have here a callback that is bind to an event of type click. Okay? If I move to the second example, here I have a nice real world example. This example is, for example, for displaying an image to the screen. Okay? What do I have here? I have a function called add image. It accepts src source. Okay? Then I'm creating an image element. Okay? Then what I'm doing here? I'm binding or appending the new element, the image, to the body. Okay? Simple. Okay? Do you have any problem here with this first function? Any question? Any? Great. This is simple, straightforward. I have also here's the nice part or the tricky part, the second part. Function load image. This is a function. What accepts this function? It accepts two parameters. Okay? Two parameters. We have the first one, which is URL or src. Okay? We have the second parameter, which is a callback. Okay? Great. Inside we are creating a new image. Okay? We're creating an empty image. Then we are adding an event listener called load. So we are listening for the image to load. Okay? Then once the image is loaded, we have this. What we call this? What do we call this? Callback. Okay? We have this callback executed. And inside this callback, we have also another callback. So we have two callbacks, one nested inside the other. Okay, we have this the most outer callback, and this is the most or the inner callback. Okay, so we are listening to the load event. Then if I try to scroll down a little bit here, what I have here, I'm adding also, or I'm subscribing to the event also, the error event. Okay, the error event is fired when there is an error. For example, the image doesn't exist. Okay, for example, I'm trying to load the image called abc.jpg, for example, and the image doesn't exist. Okay, an error will be fired. Okay, and inside this function, I'm just trying, once the error is spotted, then I have this function to execute. We have a message, couldn't load the image, then with URL. Okay, and we have also here, okay, the image.src equal URL. Okay, in your opinion, what is the execution or the order of execution? We have this one. Then, is it this one or the other? Can you give us the order of functions? This is the first, let's say, event listener. Okay, this is the second event listener, and this is the third or the last instruction. Will get executed first. Is it this or this?
What is the one at the bottom?
The one?
Source, so both source.
Excellent. This will be executed right away. Why? Because it's, why? Just to try to remember what we've said previously. Why this will get executed immediately? Because it's in the main queue. Okay? This is why. It's in the main queue, so it doesn't have to wait for anything. It's there, it's the first one, so it will get executed immediately, or okay, or right away. Okay, this is the first one. We have then these two events. These are events, or as we call them, subscriptions. Okay? Once this event is fired, execute this function. Okay? Once I have an error, execute this one. Okay? So it depends on the event. Okay? So we have here two event listener. If I'm trying to implement this example, I have already an example here called examples, image upload. Yes, this one. Index.html. Okay, let's just view in the browser. Yeah. Here I have just three simple, okay, pictures. If I try to analyze or just read through the code source, I have here, I'm loading the two scripts. I have a script called load images callback.js. Okay, it's this one. The one we saw earlier. Okay, it's a simple code we have here. Okay, load image. Okay, and we have also, what do we have also? Add image. Okay, add image is also this one. So it's simple function. Okay, it accepts an src attribute, then it will create an image based on this src, then it will append the new element to the body. Okay, so it will create an EMG element, then it will bind it or append it to the body, okay, of the page. Great. Okay, then what do we have also here? Okay. That's it. Okay, what I'm doing here, what do we call this? I'm calling the load image. I'm trying to load the image one. Okay. Then inside the image one, what I'm doing here. What I'm doing here. This function load image. I'm trying to load the image called 01.jpg. Okay. Then I have, what is called this? This one is called a callback. This is a callback. This is Node.js style. Okay. Where we have the first argument as an error, if there is an error. Okay. And the second is the data or the information that we want to pass. Okay. I'm trying to load the image one. Okay. And then inside this image, what I'm doing, I'm adding add image. Okay. I'm adding the image to the body, okay? Then, if this is a successful operation, then I move to this one, load image 0 or o2 dot jpg. Then same thing, I'm adding the second. Then also I'm adding the third image. This pattern, what we call this pattern? It's a well-known pattern. What do we call it? Yeah, the callback paradise. The callback hell. Why we call it callback hell? Let's not. Yeah. What's the problem here? Is it the code nested here?
It's difficult to manage something error happens. You have to track the.
Excellent. You have, if for example I have an error here. For example, let's say this first one, I'm trying to load the image 01, and this one doesn't exist. It means that I will get an error here, okay? So I have to manage or put the case of dealing with error here. The same thing goes here, and the same thing goes here. So it's a lot of code to manage simple. This is just simple, very simple example. Use examples like what our Facebook doing or Twitter, it would be total crash. Okay, this is just simple example. We have here what we call a callback hell. Okay, why? Because we have nested callback. We have this callback, and here a second callback inside the first callback, and we have also a third callback inside the inner callback. Okay, this is just simple example. I'm not trying to complicate. This is the most simple example that you can find about callback execution. Okay, this is a big problem with callbacks. Okay, so to solve this problem, generally we use what we call event-based messaging. Okay, so we have two environment, or not environment, but two pieces of code executing in separate concerns or in separate spaces, and once this element tries to communicate with the other element, what's the method here? We have messaging. Okay, we have messaging. So I need, for example, to access a variable that is located in the other part. I only send a message, and the message will be received, then treated, then I get the response. Okay, this is one solution. It's event-based solution. Okay, and when it comes to events are very simple. We have what we call the pub/sub or publisher subscriber pattern. Okay, have you ever heard about that pattern? The publisher subscriber pattern. I have a publisher and subscriber pattern. It's like a producer consumer pattern. Okay, I have a consumer, I have producer. Okay, it's very simple. I have here, I've just set up an example here in helpers. What is it? In helpers. Yeah. Let's move this. It's not too confused. Okay. This is the Node.js style. I have a function called emitter. I can call it event emitter. Okay. Okay. It has a list of events. Okay. Then I'm adding to the prototype an emit property. Okay. Emit equals event type data. Okay. Then this event type map function callback.call no data. Okay. What we are doing here? What we are doing here? It's like Chinese. What we are doing here?
Is this a solution for callback?
Yeah. A solution, a part of the solution, one of the solutions. Yeah, for the callback. This is the event-based solution. Good for simple cases, but when it gets complicated, it's not that good. It has also its drawbacks. Okay. What we are doing here? We have the emit. Okay. Emit, which means publish an event. Okay. We have here what we are doing here. We have the event type, as we've said earlier. For example, in the DOM or in the browser environment, we have, for example, the click event, the hover event, the mouse down event, the key up, key down events, the scrolling event. We have a lot of events. Okay. Page load event. Okay. We have a lot of events. This is the same thing. We have emitting, so we are emitting event. Here is the event type, and beside the event type, we have also the data. Okay. So for example, when I scroll the page, what is the data that I want to send to the listeners? Okay, the listeners. Okay, this is. We have also the listeners stocked in the events. Okay, so we have this events, event type, okay, map. Then we call every single callback. Okay, we have also here this emitter prototype on function. So when I have the event on, I will grab the event type. Then I will go to the event, the events object, and I will look for the event type. Then try to execute all the events. Okay. So if I try to execute this example, I have this code. Oops. I have here. I've set up a simple example here, but let's just remove it here. Where, for example, let's say A equal new emitter. Okay, I can even call it event emitter. Okay, for the sake of simplicity. Okay. Okay, then I have A. Okay, will listen, or I don't have listen, I have on. Let's say, for example, let's create a custom event. Give me a name, custom event. You can call it whatever you want. For example, give us a name, any name. Bulmaz. What does that mean? What does that mean?
Well, nothing.
What?
Nothing. Okay.
Okay. Let's give okay. Let's give it, for example, on OK. So when the OK event is fired, I want on OK function. I want to execute this function. Okay? Let's give it data. Okay? We call it data. And we're trying here console. We are just log in to the console. Okay? Console.log data. Okay? Then I should have, so I'm subscribing to the OK event. Okay? So I'm saying when the OK event is fired on the A object, I want to execute this callback. In other words, I'm trying to console, to log to the console the data that was emitted with the OK event. Okay? Now here I have A dot emit OK what I have here, I have this simple three helpers or three simple functions. Okay, this is called the constructor. Okay, this is the event emitter. I have also two methods, emit and emit and on. So here I'm creating a new event or new object A that has a lot of event listeners. So when the OK event is fired, I will log to the console the data that was accorded to that event. So this is why I'm doing here a.emit OK. Okay? And I'm sending with the event, what I'm sending? What is this? Yeah, this is the object with a message property. Okay, with only one property. Okay? And now, if I execute to the console, what I will get?
You forgot to change the name of prototypes.
Where?
You still
Where?
write an internet on prototype.
Where? Here? Hey. Okay. Great. So now, what I'm getting here? Okay, message. I can even try to do different thing here. I can say, for example, console.log. Okay, event was fired. Okay, now if I try to console, what I have here? Okay, event was fired. Okay, I can define any custom event. Okay, I can, for example, define an event called arrive. Any name of event. You can pretty much define any type. This is called the event-driven model. Okay, it's an event-based model to communicate between elements. Okay, so this is the event-based. Now I have only simple case. We have okay. I can use a lot of events. Okay, I have okay here. We have only one function subscribe to the okay. Yeah? Okay event. I can also add another function. For example, a dot on okay function data console.log example. Just an example. What I have here? What do I have here? I have what I have here? I have two callbacks. Great. Two subscriptions for the same event. Okay, for the same event. For the OK event, I have two subscriptions. I have this one, and this second callback. I can add as many as I wish. Okay, 10, 3, 40, depends. Okay, this is just an example. And now if I execute this function, what do I get? OK, event was fired, message, hello, then ABC. Okay, why? Because I have two subscribers to the event. Okay, I have this subscriber. Okay, and they have also this second subscriber. Okay, do you have any question till now? Any question? Is it clear? Ambiguous? I think it's this is a clear example. This is just sim. Okay, great. This is the event-based solution. Okay, this is what you would see normally in the Node.js environment. Okay, if you use Node.js, you will see a lot of event-based. You will see a lot of the event model. Okay, in Node.js environment. Great. This is the callback. We have also, what do we call? Thanks or thanks. Okay, this is the callback. What is a thank? Thank. What is a thank?
Symbol closure. So a function that returns another function that will use something from its internal state.
A function? Can you simplify it a little bit? It's a function.
So for async, in the context of async.
Yeah, it's used for both, for synchronous and asynchronous code. It's used for both cases.
For what cases?
Yeah. But in synchronous code, we don't have problem. If your code is all synchronous, there is no problem. The first one is executed, then second one, the third one. There is no problem when you have a synchronous code. It's obvious. The first one, second one, third one. The problem rises when we have asynchronous code. Okay? When it's not obvious. Okay, please go ahead.
In the context of asynchronous, it won't return a function. It will call the async function. We give it. Actually, it will call our callback after that async function
Give us
is
some.
finished.
Yeah, great.
So
Give us
it will run
feedback.
it will run the async function inside, and then callback. Invoke our callback, then let us continue.
Okay, it's something like that. Not that exactly, but something like that. If we can put it simple, it's a function that already have or has anything it needs to return value. This is pretty ambiguous here. Okay, this is a function that has already what it needs to get executed and to return a value. Okay, if I come here, let me just go straight to the example so we will understand better. Okay, if I come here in the call thanks, okay, I have the first example. This is the simple thank. I have simple thank here. What do I have here? Simple thank. What I have the function called add. It accepts two parameters. We have the x and y, okay, and add some. This is called a thank. Okay. This thank obviously is useless thank. Why? Because why this is useless? Why this is useless? Yeah, because we have hard-coded values, okay? In real world, 1 and 2 would be parameters, not hard-coded values, okay? This is the simple, but this is called thunk, okay? And once I call thunk, I have this thunk equal a function. And this function return a value, okay? So now if I log to the console, this is synchronous thunk, by the way. If I log to the console, what do I get? Unsurprisingly enough, 3. Okay, because 1 plus 2 equal 3. This is the synchronous thunk. If we get to the asynchronous thunk, let's just switch here. To make an asynchronous thunk, we can only add a timer, okay, and it will change the game. Just add simple timer, okay. We don't need to add the server, or just add simple callback, simple timer. We are adding here. We have async add or asynchronous addition. It accepts 2 or 3 parameters. We have the x and the y, and we have also the CB. This CB stands for callback. Okay, this CB stands for callback. Okay, set timeout. I'm using set timeout. So timer. I'm using timer that waits for 1000 milliseconds, which means 1 second. Okay, and this 1 second has passed. This callback is executed or is called with the 2 variables, x plus this one. Okay, then we have here our thunk, and there is one condition about thanks. Thanks only accept 1 argument. Okay, and that argument must be a function. Okay, so thanks accept only 1 argument, and that argument is a function or a callback. Okay, so what I'm doing here, I'm passing to the thank equal function. I'm passing only the call back. Okay, and here I'm adding 1 plus 2. Add asynchronous addition 1 plus 2, then the callback. Okay, and here I'm executing the thunk. So this thunk is a function, and once I call the thunk, what do I get? I call the thunk, then I must pass or provide a function with a parameter, a first parameter. What's the value of this parameter? What is the value here? Why it's 3? Yeah, why? Because we have the thank equal a function that accepts only a callback, okay? And we will use asynchronous add, which is the function here, and this one, once this time has passed, it will call the callback. So the callback is not executed immediately, or it's not executed right away. This callback is waiting for 1 second. Okay, it depends. In real world, it depends. For example, if you ask for data from the server, it depends. Maybe 2 milliseconds, maybe 3, maybe 1 hour, maybe you won't get it. Okay, this is the asynchronous code. Okay, so we have set timeout. Okay, so this is asynchronous code. Okay, this is the asynchronous code. We've seen the synchronous thunk. This is the asynchronous thunk. Okay, simple asynchronous thunk. And if I jump right away to the third example, we get to the interesting solution about thunks. Okay, we have, this is the general purpose thunk. Okay, so you can use it pretty much for any case. We have here asynchronous add, the same function. It accepts 3 parameters. We have the x and y and cb. Okay, then we call. We have also here the make thunk, which is a helper function. Okay, the make thunk. What's the job of this function? It's, as the name says, make thunk. So it will create a thunk. Okay, so what we are doing here, we are passing a function. Then we are taking all the arguments. Okay, removing the first argument. Why? Because the first argument refers to the fun, okay, or function. Okay, then what we are returning? We are returning a function. That function accepts the CB. Okay, accepts the CB. Okay, Then the args.push, we are pushing to the argument list, the CB. Then we are calling the fn with the args. Okay? It's a little bit confusing here, but give it 2 or 3 times and you will understand it. Okay? And here I'm making a thunk. I'm making a thunk with async add with the values 1, 2. Okay? Now if I call it, I have here this thunk. Okay, I have this thunk. I just created make thunk. So I called it thunk2. I can remove this thunk2 and call it just thunk. Okay, if I execute, I will get nothing. Why? Because the thunk has not already received the value. In order to get the value that is coming in the future, the value is coming in the future, not right away. In order to get it, I just have to thunk. What I should pass to the thunk? What is the argument to the thunk? A callback. Excellent. So I have to pass a callback. Callback with an argument. Okay? Let's call this what we call it. For example, in our case, we call it sum. Why? Because we are summing x plus this y. Okay? So if I log to the console, console.log sum, I will get. Okay? So I was waiting for a little bit, for 1 second. If I try to change it, let's say, not 1 second, but let's assume 5 seconds. Okay? You will see that the result will not appear right away. It will wait for 5 seconds. Okay? If I click here, if I execute again this code, 1, 2, 3, 4, come on, 5. Okay, there is 5. This is what we call asynchronous code. You don't get the value right away, so you can't even manipulate the value. Okay? For example, you have x, then inside your code you're trying to x equal x plus, but wait, x hasn't already received the previous value. Okay? Okay, so this is the thunk. Now, imagine we would like to access the same value here in another part of the code. Okay? This is what is generally the case. I'm trying here access the value of sum. If I'm using a callback, I must, and there is only one solution, which is to include all the code inside the main callback. Okay? If I'm trying to access a variable that is accessible inside the callback, it's visible and available only inside that callback. Okay? If I call it from outside, there is a risk that it's not already defined. Okay? So I have to put all my code inside that callback. So I will get a big callback. Okay? Whereas when I'm using this thunks, I have this thunk. Now if I'm trying to use sum, or if I need sum for the second time, or for the 10th time, or for the xth time, what I do, simply by calling okay. So here, I needed to access the value of sum. I called the thunk with the callback. And here, down my code, I needed also to access the sum for a second time. What I've done, I've just called the thunk for the second time. Okay? So this is the advantage of thunks. Okay? So instead of putting all your code inside one big callback function, you have your thunk defined at the beginning, or just in front, or at the beginning of your code. Then you have this thunk, and once you want to access the value, just call that thunk. Okay? So I needed to access the value here. I call this thunk. I needed to access it here. The same thing if I want to access it somewhere else. Let's say, for example, now here I want also to access the value. Okay? If I try to execute, what do I get? Three, then 3, 3, 3. Why? 3 for the first time. I'm waiting for 5 seconds. Then once I've done waiting for 5 seconds, I have 3 available for me. So I just have to call the thank. Okay? So this is the advantage of thanks. Thanks. Okay? And from here, we start to, thanks are a little bit like promises. We will get them just a little bit. We have thanks. Thanks operates almost the same as promises. Promises with some nice, with just a nice API with some additions and okay. So this is what we call thank. Okay. So I'm accessing a value that's not available now. I don't care if some is available or not. I have my callback, and once it's available, it will get executed. Okay. This is what we call also in promises. We will see in a few. This is what we call a container for value, or a time-independent container for value. What does it mean, a time-independent container? It means a container that's holding a value that is independent from time. What's the meaning of this? Let's try to simplify, or to simplify this, these 2 words. Time-independent container for value. I have a value that's coming in the future. Future doesn't mean next day or next week. It can be now, it can be after 10 seconds, it can be after 10 hours, it can be after 10 years, okay? It's a value that's coming in the future, okay? So if I use thanks, worrying about how or when I get the value becomes something secondary. I don't have to worry about when the value comes. I just have to use my thank. Because here, I'm not worrying about or when I get the sum. I'm just calling the thank with the value, with the callback. Once the thank get the value, this will get executed. Here the same thing. Once the thank get the value, this will get executed. Okay? So this is called thank. Okay? Do you have any question here? Thanks. Is it clear first? Who didn't understand the thanks? Thank. Can I ask you a question? If I try to use sum here, what is the value of sum here? Here, sum. If I'm trying to consult to the consult with log sum. Excellent, and defined. It may be defined if, for example, if I'm lucky and this get executed after the value just come back from the server. Maybe you're lucky, but not all the time. Okay? It can be holding a value as it can be undefined. But in most cases, it's undefined. Okay? So to eliminate this problem, we are using thanks. Okay? We are using thanks. Now we move to the next concept. This is called thanks. So here thanks, I'm using this sum. Whenever I need to access the sum, I just need to call the thank. Thank, then I pass. For example, I'm trying to multiply the value of sum. For example, sum multiplied by 2. What I do, for example, here I need it somewhere for my code. Okay. What I do here, okay, so if I need somewhere else in my code, I just use the thank with a callback. And inside that callback, I can access the value of sum. Okay, so here there is another notice or caution here. We have sum. This is sum, the same thing. Sum and sum. They are holding the same value. Okay, it's the same value used in different parts of the program. Okay, it's the same value used across or in different parts of the program or the application. Okay, this is thanks. Now we get to the promises. It's something similar to thanks with just a little bit of. Okay, so this is thank. This is promises. Promises are the same thing as as thanks, okay? Just with some differences and some conditions, okay? First of all, promise is a time-independent wrapper around the value or a value container that's independent from time, okay? The same as we said about thanks, okay? A promise, for example, for instance, to illustrate on this, a promise could be, for example, if you go to, for example, to a restaurant, for example, okay? And you order, let's say, I don't know, you order something, okay? Let's say you order, I don't know, something, for example, let's say chicken or I don't know, something. You ask for chicken. The first thing you do here in Turkey, and I think in all over the world, you will pay first. Even you didn't get the chicken, you will pay first. You will pay the price of the chicken or what's your order, and what you get instead of your order, what you get recipe or bill, or okay. So you get it. It's a promise that in the future you will get chicken, for example. It's a promise. Okay, and on that promise, you can build something. For example, I can invite my children and my friends. Just join me. I'm eating chicken, for example. Okay, so you are building some decisions based on promise. A promise is like we say in our normal life. Promise is something that can happen in the future, and it may never happen. It's just promise. Okay, this is the same thing here. We have promise. Okay, a promise is something that may happen in the future, as it may not happen for some reasons. Okay, the condition about promises is that they are resolved only once. Okay, so once it's resolved, there is no second time. Once it's resolved, there is no second time. If I come here in JavaScript context, okay, I have the promises. Okay, this is the promises, or in simple, as a simple example, we have save. Okay, okay. We have here promises. Oops. We have the console here. To create a promise in JavaScript, simply use the word new, or let's say a equal new promise, okay, and pass in the callback function. Okay, so we are using the promise constructor or function, okay, with the capital P. Then we are having this callback. Inside this callback, we need two arguments. We need the resolve and reject. Okay? The resolve is the callback that is executed when the response resolves. Okay? When the promise is done successfully, we execute this resolve function. Okay? It's a callback. We have also reject, which is another callback that is executed when we get an error. Okay? If there is an error, we use this reject. Okay, this is the most simple case for promises. Okay, so I have here in my examples, I have some promises here. If I come here, promises. In the first example, yes, I'm using promises with delay. Okay, so I'm using timer here. What I'm creating here, I'm passing the time, and I'm creating a promise. Okay, I'm returning a new promise, okay, with a resolve and reject, and I'm setting timeout. And when the timeout has passed or collapsed, what I use resolve and time. Okay? Okay, so once this timeout has passed, we call the resolve. Resolve as the first callback. And we have also the second time. Okay? Because the general syntax of set timeout is this: set timeout, callback, then delay or time. Okay? So this is the same thing. We have resolve. Okay? This is called delay. It's a function that returns a promise. It's a function, simple function that returns a promise. Okay? I have here, what I have here, I have delay 100, millisecond, okay? And in promises also we have two or mainly two methods. We have then and we have catch. And we have also reject and the others. But the main two methods or two properties, two methods are then and catch. We use then to receive the result of the promise. In this case, I'm delaying 100 milliseconds, then I'm calling this function. Okay? So I'm calling this delay function here with 100. Okay? So 100 is 100 milliseconds. Okay? And then I execute this function. This function is the same as if I call it result. Okay? So in this example, I'm not passing the reject callback. I'm only passing the resolve callback. Okay? So once delay has passed with the 100 millisecond, I'm calling then with the resolve callback. Okay? Okay, so I'm having also here delay. Let's try to comment out this part. Okay, so this is okay. So if I come here, oops. Okay, so I'm having delay function, then a delay is executed and returns a promise, and then we are adding then to the promise. Okay, what I get first. Okay, this is the first. Okay, and if I come here and try, instead of using delay, I'm storing delay in variable. Let's call it prom, for example. Prom equal delay. Let's just call the function delay. It's a delay with 100 milliseconds. Okay, we said the return value is a new promise. Okay, so this prom variable is holding a new promise. Okay, so if I execute this code, I get new promise. And if I try to just inspect the value of prom, okay, I get promise. Why? Because this delay returns a promise. Okay? Great. Now I have a promise. Now I'm trying to access the promise. I have prom. We have also then. If I try to inspect here the prom, if I open the prom, I get a lot of promise prototype. If I try to inspect, I'll open this up. What do I have here? I have then and catch. Okay, then for chaining promises, do you know about chaining? Have you ever heard about chaining? When you have promise, then another promise, then another promise, etc. Okay, it's like in jQuery, for example, you have this one. For example, in jQuery you have for example first, then for example fade. Okay. You have, for example, here, you have, for example, let's say, ET, for example. So you are grabbing or taking all the elements with the class ET, then you are taking only the first one, then applying fade animation to it. Okay, this is called chaining. Okay, chaining. So you can access function or execute the same function from the same context. Okay, we have then. Okay, we have then and catch. If I try to access then, okay, I have here a prom, then I have function. Okay, here inside this function, this is called resolve function. Okay, and we have also, we can add the second, which is called function, which is called exception or reject. Okay, Okay, we have here the two functions. We have the resolve function. We have also the reject function. Okay, and the things that goes inside this resolve function is when the operation has executed successfully. Okay, and reject will be used to track if there is any errors. Okay, so when the prompts resolve, we use then, and we pass the first argument to then, the function or the callback for successfully done, and we have also the reject when if there is any problem or if there is any error raised by this prompts. Okay, to use a real world example, I have this example here. Oops. What I'm having here, I have delay. I'm calling delay with 100 milliseconds. Okay, then I'm resolving the promise, the first promise, and I'm logging to the console first. Then I'm returning a new delay. If I return a new delay, if I'm returning new delay, which is a new promise, this promise will be the element that we are chaining from. So this dot then is applied on this new delay 300. Okay, so I'm chaining from this promise, I'm chaining here. Okay, and I'm logging to the console second, and here I'm throwing an error. Okay, I do it intentionally. I'm throwing a new error. Okay, then I'm trying delay. Okay, in this case, what we have the first delay, we have the then, we have a resolve function. We will log to the console the first, then we arrive to the second call to then. What do we have here? We have this resolve function. We will log to the console second, then oops, wait, we have an error here. Okay, so it will jump right away to the catch. Why? Because there is a problem or an error here. So it will bubbles up to that catch. Okay, so if I execute this code, this snippet of code, if I use this snippet of code, if I'm having here, okay, let's try to reduce the font size. So I'm having delay, blah, blah, etc. So I get the first message logged to the console. I get also the second message logged to the console. At the third element, oops, an error occurred, oops, and this is the message. Okay, why? Because there is an error here. Okay, an error spotted here. Okay, so there is an error here. Okay, and whenever there is an error, all the promises or the promise chain will stop continuing. Why? Because there is an error. Okay, so for example, I have the first chain, second, third, and in the second chain I have an error. The third chain will not be executed, and the error will bubbles up to be executed or to be catched here. I have a catch. Okay, and whenever I catch an error, for example in this case, I just log to the console the error itself. Okay, so an error occurred and then log to the console the error. Okay, so this is the first case or the first example of promises. Promises do have a nice API, better than Thunk, because Thunks, they are a little bit ugly. Okay, promises do have a nice API and have also this notion of trust. A promise can only resolves once. So when a promise resolves once, it won't resolve for a second or third or fourth or any number of times. Okay, so it will resolve only once, and then it will be immutable. So the data that was resolved inside that promise won't be changed. Okay, so if I go to the second example here, this is the first example. If I go to the second, bear with me here. I'm using promises with the callback. What we called it with the callback? How? Okay. You gotta be careful here with the promises. You have also what we call promises hell. If you find yourself in promises hell, just get your hand from your keyboard and go take a walk, or then come back. Okay? Don't ever, because the whole point of promises is to avoid and to eliminate callbacks. If you are using promises like this and you are chaining like using callback hell, you're doing nothing. Okay? So the whole point of promises is to eliminate the problem of callback hell. Okay? So you have only one place, for example, to manage all the errors. Okay? So this is, please stop using this code. Okay? And I see a lot of this code like this in the internet, for example, especially in npm modules. Okay? It's like Wikipedia for JavaScript libraries and scripts. Okay? This is the second. This is the bad way to use promises. They are here to resolve or to solve the problem of callback hell. We won't use them to create another callback hell. Okay? We have also here, this is a real world example. For example, I'm fetching or I'm getting data from the server. Here I have server, localhost, colon, 3000/users. I'm getting data from this, and I'm applying then. Because the fetch API, if you know the fetch API is a promises-based API. So the result will be a promise, and promise with the rejection and resolve, okay, with the fulfilled and the rejected responses. Okay, I have a fetch API. Okay, I'm fetching data from this location. Okay, localhost colon 3000/users, and whenever then I execute this function. There is a response here. Okay, I'm having a response. If response dot status, as we've said previously, is different than 200, it means that looks like there is a problem. Why? Because if it's different than 200, there is two possibilities, whether it's 404 or 500. 500 means there is an internal error, and 404 means the resource was not found. Okay, so there is an error there. Okay, if the status is different than 200, there is an error here. Okay, and we return silently without doing anything. Okay, we are just logging to the console. There is a small problem here. Okay, if we pass this part means that we get successfully, or we get a result from the server. The response is stored in response.json. We call the method JSON. Then, and inside or on top of then on the JSON, we pass to it another callback. Okay, we have another callback here. Okay, the callback with the data in it. And here I'm logging to the console. I'm stringifying the JSON version of the data. Okay, and here if I get any error, I will fetch error and then display the error. Okay, and I have here a simple file called data.json. Okay, so this is the source where I get my data. Okay, so I'm getting my data from this file, data.json. Okay, so I'm getting my data from this file, and this file is hosted on a local host. If I come here, oops, JSON, I'm using JSON server. Okay, so I have a fresh server launched from this location. If I browse to this location, oops. Okay, if I come here, okay, so I'm getting all the data. Okay, localhost, okay, 3000, etc. I'm getting all the users, and if I remove the users, okay, I'm getting the whole collection. Okay, if I come here, oops, I'm having two users. If I add third user, it would be something like this. Okay. Why? Because I launched the server from previously before I add the, so I have to, relaunch the server. If I add relaunch the server, I get the third user here, okay? So this is the third user, okay? I have an array of users, The first object is a user, the second object is a user, and third one also is a user, okay? So I'm using also the fetch API. It's an alternative for the jQuery dot Ajax, okay? It's the alternative for jQuery Ajax. It's called the fetch, okay? And the return value from fetch is a promise, okay? So this is why I'm getting here. This is why I'm getting here, a promise, okay? Fetch, I'm fetching the data. If I put this, okay? If I put this here, okay, I'm fetching the data from this URL, okay, from localhost users /users, okay? So A, then A, as we said, A will return a promise, as we are saying here, okay, a promise. Then A dot then we pass the first argument as the resolve, okay? We have here the response object, okay? If I try to console log the response, okay, the response object, what I will get, this is the response object, okay? If I try, we have also, what do we have in the response object? We have the status property. It's equal to 200, which means the request completed successfully, okay? So if I come here, so instead of logging to the console the response object, okay, I will, as we said, if response dot status is different than 200, this means console.log error, okay, and we will return, okay? Otherwise, we'll try to display the data. We will do console.log response dot or response dot JSON, okay? Then on the JSON we have then. Okay, so if I try to execute that, what do I get? Do I get the server response, and I've get 2 or 3 array of 3 objects. Okay, if I try to inspect these 3 objects, the first object is the first user. Okay, the second object is the second user, and obviously the third object is the third user. Okay, so this is a promise. Okay, if I try to make this a general purpose promise, so instead of every time I go to response.json.then, I can simplify it by replacing this by returning, instead of using it just like this, I will return, okay, and here I will remove this function. I have here function return data. Okay, So instead of returning the stringified version, I'm returning the data itself, okay? So if I come here and try to copy then this, if I come here, okay, fetch. Now the only thing I have to do is then receiving directly the data instead of receiving the response, then handling the response, okay? So here I'm receiving directly the data, okay? And I can also console log data, okay? So I'm logging the data to the console, okay? It's the same thing, okay? So this, the second way is nicer or cleaner way, okay? So instead of using a.response.json then adding a promise or a callback, I'm using directly the a then and passing the callback to the a, okay? So this is cleaner way, okay? So this is a cleaner way. So returning a promise, and inside the promise, this resolve callback, I'm passing or I'm returning the data, okay? So the only thing I have to do is a dot then accessing the data, okay? So this is the third example, using fetch, which is a real world example, okay, the fetch example. We have also what we call, we have a lot of abstraction layers, because in the promises we have a lot of.
I was going to ask actually the JSON server. I'm using HTTP server and I haven't heard JSON. What's the difference? Or what should I choose if?
You just need the server. In my case, I have JSON server. I'm using. No. Server is just a way to get to serve data from a server. You can use PHP or you can use, I don't know. You can use you can use Node.js. I'm just using a service called JSON server. Okay, it's just service. Okay, it's just like PHP. So I have data in the server and I'm asking for the data. Okay, so give me the list of the users. I'm asking for the users list and I get it back, okay? That's it. Do you have any questions, guys? Questions? It's like you're watching Chinese movie. Okay, so this is the promise with the real world example, okay? Now, imagine, for example, I get the list of users and here I'm trying to display or to log to the console the users or the list of users. So here, as we've said, I will use a dot then pass in the callback, my callback. Okay, then inside that callback I'm having here the data. Okay, console. Okay, I'm logging to the console. Okay, let's assume here in my code I'm trying to display only the first user. What I will do, I have this code. I can copy this code. Then, instead of displaying the whole data, I will display only the first element. Okay, and so on. If I grab this piece of code and try to execute it there, oops. Okay, so I'm fetching or I'm looking for the users list, and once I get it, I'm logging the list of users to the console. Then I'm logging only the first user. It can be whatever you want. Okay, it's just a simple example. I'm using the first user. Okay. Okay, so I get here the list of users logged to the console, and here in the second, what did I get? The first user. Okay, this is the first user. Okay, this is promises. Okay, and as we've said, promises can only resolve only once, or can be executed, not really executed, but can resolve only once. The term resolve meaning it can only hold one value, and once it gets that value, it won't change. Okay, it will never change. Okay. That is what we call immutable. which means that a structure that you can change the value. Okay, this is what we call immutable. Okay, this is the promises. This is the promise solution. We have also, beside the promise solution, we have the last element in the list, which is generators. Okay, generators. Okay, if I come here, okay, let's just come back to the slides and see. Did we stop? The generators. Okay, so this is the point. Okay, so generators are, this is the fun or the funny or the interesting part. Generators are posable functions. Generator is a function that you can pose. What a big deal. Do you know what does that mean? A posable function. It means a function that you can pause or that you can stop or on. Okay, if I come here, at the first time it won't sound a big deal, but once you give it a try 1 week, 2 weeks, maybe 2 years, maybe 3, you will understand a little bit what's the goal or what's the purpose behind these generators. Okay, in order to use a generator in JavaScript, it's simple. The only thing that you have to use is the same definition as a function, only add this asterisk or this star symbol. Okay, so this function gen, so it's not a normal function, it's a generator. Okay, why it's a generator? Because we have this star in front of the name of the callback. Okay, and we have also the new keyword called yield. Okay, yield, it's the point that we are stopping. It's like here we are pausing. Okay, it's like this. Here we are pausing, and here we are also pausing. Okay, so this is the yield. For example, in this case, and in order to use the generator, you have to call it. Okay, and we have here the first call. Okay, we have it equal gen. We are calling the generator gen. In the normal function or in the case of normal function, once you call the function with a parenthesis, it's called a function execution, or you are calling the function. In the case of generator, it's not executing the generator. It's creating a new iterator. Okay, iterator, it's a known pattern. Okay, an iterator, it's a structure that, for example, you have data and you have an iterator that goes through the data. Okay, this is called an iterator. For example, if I come here, I have small helper. This one is an iterator. Okay, it's a data structure. Okay, a data structure with data in it. For example, in this case, my data is first, second, and third. Okay, I have also the length property. Okay, I have the index, and every time I call next, what do I get? I get value. For example, I call next for the first time, I get the first value. The second time I call next, I get the second value, etc. Okay, I'm getting first, then I got second, then I got third, and once there is no element, what's the result? If index equal length, the returned value will be undefined. Okay, so it's simple here. So if I try to execute, what do I get? Okay, so I'm having first, because the first value is first, then I'm getting second, then third, then I'm getting undefined. Why? Because there is no value left on the data. Okay, so there is no value left, so I'm getting undefined. Also the same thing goes for this next. I'm calling next on A, and A doesn't have any more data. Okay, this is why I'm getting undefined. This is called the iterator pattern. Okay, it's a simple pattern. Okay, so instead of using a loop, we are using dot next. Okay, let's get back to our generator. Okay, so here, as we've said, we will get a generator as a response. Okay, so if I use this, okay, if I use this, I have generator, and here I'm creating the iterator. Okay. Now the generator, what is the core of the generator? We have the console.log, hello, earth, then citizens. Okay. Now once I call it, which is the iterator dot next. Okay. It dot next. I will get hello. Why? Because hello is the first execution or the first code in the program. Then I get to the second, to this yield word or this yield keyword. My generator will be or will pause in this part. Okay. So I need another dot next. Okay, in order to resume my generator. So I will use it dot next. Okay. Once I call it dot next, I will get this earth. Why? Because my generator resumed from this yield, so the first instruction was earth, so it was displayed to the console. Okay, and you can notice here I'm getting an object, the value. Why? Because I'm not getting a value with the yield. Okay, now if I call it for the next for the third time, I get citizens. Okay, and I will get also a different attribute. You can notice here in the first time I get done equal false, because we're not done dealing with this iterator. Here the same thing, we have false, done. We have in the third citizens done equal true. Why? Because my iterator has complete. Okay?
What is you type once? What if you type once again?
The result will be value equal undefined and done equal done. So there is no data left in the generator. If I use it here, okay?
I will get back to the previous.
To the previous, which one? To the,
For example, students.
to the,
Students.
you're talking about this, this snippet of code?
With next, we execute the next step, but if we want to execute the previous step, is there any keyword for it?
No, you can't go back.
It's one.
It's one way. It's like getting data. Get first, second, third. You can't go back. This is the whole point. It's the iterator pattern. So you get the first, then second, third, etc. You can't go back. It's like instead of next, you have a prev or previous to get the previous. No, there is no. Okay, so this is the first. Okay, this is the first case. So I'm getting here next, next. Okay, oops. So this is why I'm getting next, because the first one is hello. And when I call next for the second time, I get earth. Okay, yield. Then I got citizens. Okay, this is the simple example. Now if I move to the second example, I have also a generator called main, and here I'm creating the iterator to iterate through this generator. Okay, so I'm calling m1.next, so I will get 1. Why? Because the yield, there is a value after the yield keyword. Okay, when we yield a value, that value is passed, is the return value of next. Okay, so I'm yielding 1, so I will get it in the return of next. So value 1 done equal false. Okay, because it's not done yet, has not done yet. So in the second one we have m1.next. Okay, we have the same thing, value 2. Why 2? Because we are yielding the value 2. The third one, the same thing, we are yielding the value 3. Okay, and we have here done false. Once we call m1.next, and we don't have any last yield, the returned value from the next call would be value equal undefined. Okay, because there is nothing to return. And we have also done equal true, which means this generator has complete. Okay, value is undefined. Why value is undefined? Can you give us the reason behind this? Why value equals undefined? Why?
There is nothing in the list to be.
Yeah, there is nothing in this, but what's the technical reason behind it? It's obvious there is no element in the list. Why?
That means you use the internal loop, which is as a one you should offer.
There is no object text, no? Because we
There is
share-
no value left in the data, that's for sure. But why I'm getting undefined? It's not about there is no value. Because, as we all know, in JavaScript, if a function doesn't return a thing, the default value would be undefined. Okay? So I have here, this yield is returning 1, this yield is returning 2, this yield is returning 3. There is nothing left here, which means implicitly undefined is returned. This is why I'm getting here undefined. If I use here return 1, it will be different story. This undefined will be replaced by 1. Okay? If I try to execute this example, okay? Okay? If I try to, no, let's step by step in order to dot next. Okay, so I'm getting the first value, which is 1. We have also done equal false. Okay, if I call m1.next for the second time, m1.next for the second time, I get the second. Okay, if I call it for the third time, I get 3. If I call it for the fourth time, I get undefined with done equal true. Okay, if I try now to add return value here, if I try to add the return value, so instead of having this, I'm having this. Okay, I have here return for example. Okay, so we have m1.next, the first value, then the second value, then the third. Okay, now if I execute the next for the fifth time, what would be the result? Great, it would be undefined. Okay, and the rest will be undefined. Obviously, this is not useful. Okay, once you get the first time you get the done equal tree, it means that your generator has completed. Okay, and it will be garbage collected by the JavaScript engine. Okay, there is no reference to it, so it will be collected, and the space in the memory will be freed or removed. Okay. Okay, so this is another simple example. If I use the third one, here I'm calling, or I'm communicating with the external world. Okay, I have the generator inside the generator, and I'm communicating with the outside of the generator. In this case, I have while true, the famous C-style while true. When you deal with the semaphores and the semaphores. So we have while true. Thankfully, you can use while true now in JavaScript. While true, which is infinite loop. Okay, going on. I have while true. I'm yielding 1. Okay, so the first time I call next, the 1 will be the output or the value. The second time will be 2. Oops. What do I get? What do I have here? Here I have yield equal 1. Okay. Here I'm passing value to the external world. Whereas here I'm accepting, or I'm waiting for value from the external world. So I'm communicating with the external world. So there is the inside or the internal system of a generator, and we have the external environment, and we are communicating with each other. So we have here, I'm passing 1 to the external world, I'm passing also 2, and here I'm waiting for a value to get from the external environment or world. Okay? So once I get the value yield, if yield equals 1, I'm logging to the console. Boom. Otherwise, I'm having also another yield here. Okay? So if I have this generator, I called it E1, standing for E1. Okay? E standing for iterator. Okay? So E.next, we will get 1. E.next, we will get 2. E.next, the program is paused here, or is paused here. If we call E1.next, then in this case we are passing a value from the outside to the inside of the generator. Okay? And this yield keyword will be replaced by 1. Okay? And we have 1 equal 1, so this console.log will be added to the screen. Okay? We have also then yield. Okay? So if I try to okay, I'm having this. E1.next. I get 1 because it's the first value. Then E1.next, I get the second value. Okay. Now if I call, I get nothing because the program is paused here in the yield keyword. Okay. Now if I call next and I pass a value, let's pass 1. So I'm passing 1 from the external side to the internal side of the iterator. So this yield will be replaced by 1. Okay. So this yield, it's like label or a placeholder for a future value. Okay. So now if I add 1, we've got this ohm. Why ohm? Because we have yield equals 1. Okay. We've done this ohm. Okay. Then we have undefined. We have also done false. Why? Because we are pausing here. We haven't done yet. Okay. We have to call E1.next for the last time. Okay. Now this is done in here. Okay. I'm here. If I add another E1, it will be, come on. Am I creating another? It's just it's E1, the same E. Why? Because of while true. How can I eliminate this problem? Not to break. No break, no return. No break, no return. Why? This is very complicated. Even for me, it was very difficult to grasp the concept. Why I get to this to repeat or to loop through? Because once I get to this yield, we said that yield is the generator is paused here. Once I call this one, it will go back. You see the point? If I don't call this yield, the last yield, the program will be paused in the final stage. Will be paused here. Okay? If I don't call .next, the program will be paused here. And I will never, ever get while to do its thing for the second and third, etc. So if I come here, I come back. By the way, this is not an easy concept to grasp. Okay? I have it, I have here it dot next. I get the first value, then the second. Oops, what is the Yeah, that's it. A1. Let's see. A1, yes. A1, 1. We get 2. Nothing. We get nothing. Why? Because I didn't pass 1. So this condition was not, this condition is not true. Okay? So I get nothing to the console. Okay? And now I'm standing here in the yield. If I never call this yield, if I never call this e.next, this generator will be blocked here. Okay? And the JavaScript engine is smart enough to recognize that there is some code blocked in some place, and it will be automatically garbage collected. So here, it's like a historical moment that we arrived to pause inside a while true. We are pausing inside a while true. I don't know if you get the point. We arrived to pause inside a while true. We are pausing inside something that's looping over time. Okay? Don't worry, try it 2, 3, 4, 5, 6, 10 times and you will get the point here. Okay? So here we are blocking. So the point here, you may never call this .next. Okay? And it will be garbage collected by JavaScript. Okay? Engine. So don't worry. So you don't have to worry about this taking space in memory. Okay? Now let's go to this real world example, this serious example. Okay? This last example. Okay? What we have here? What do we have here? We have make runner. Okay? Or create. We have a function called g, which is a generator. We have it equal the execution of generator, or let's call it here e. Iterator, which is better. Iterator. Okay. As we've said, the execution of a generator is an iterator. Okay. So I'm returning a function with iterator.next, and I'm applying it as the context of this iterator with the arguments passed to that function. Okay. So here what I have get data. I'm getting data from the server. It's just an example of getting data from the server. And I'm having here a timer, okay? Set timeout for 1 second. For 1 second. Let's just make it 100 milliseconds, okay? And when that time has passed, we will run or call run with a D, which is that generator, okay? So I have here run equal make runner function, which is this is a generator. Why? Because we have this star here. It's a generator. Okay. I have x equal 1 plus the yield. Yield what? Get data 10. And getting data is asynchronous. Why? Because I'm using set timeout. Okay. So this is asynchronous process. And this is also asynchronous. Okay. And this one is also asynchronous. Okay, this is also is this synchronous or asynchronous code? I'm playing with your minds. This one, response, is it synchronous? Will it be first executed here, or this one will be executed first, then this one, then this one, then this one? Can you give me the order, as we've done previously? The order of execution here. Can you give me the order here? In the make runner.
It will be executed after the third next iteration.
It will be the last instruction to be executed. Why? Because we have yield, which is a pausing point. So in this case, it's not like the first example when we have the last instruction executed before the others. Here what we have the yield keyword. So my program or my function here will be blocked here. Once I call next, this is resolved, and I pass to this. This is also blocked here, so I need to call it dot next for the second time. Once I call next for the second time, I come here. I came here, okay? I have also another yield, so I'm waiting here. I have to call dot next, another dot next. I will get the value, then I get to this response. Okay? There is nothing here wrong, nothing historical here, nothing, whatever. There is nothing going on here. This is, if we can pick a name, it's callback paradise, not for callback ham. What's going on here? Can anybody explain to us what's going on here? It's not about the instructor. It's like yeah, schedule, but can you simplify the a little bit?
For every 100 seconds, it will execute line by line. So at the end of
this means we get to a point where we are executing asynchronous code with synchronous fashion. We are using, it's like, yeah, it's async wait. It's async wait. But this is our solution. This is async wait in its core. Okay? What we are doing here, we are executing asynchronous code in synchronous fashion. Just like the human brain. Our brain can only execute one thing at a time. You can't talk and eat and do a lot of things. Okay? Well, maybe some people can do it. Okay? So what we are doing here, I'm having here, this is yield, get data, which is asynchronous. Okay? This one also is asynchronous, because I'm using also a timer. This response also, I'm getting the same thing, pretty much. And here, which is synchronous. And if I try to execute this whole program, if I can, if I execute this program, why?
First line,
Let's see what we have.
new iterator, return iterator next, apply, it
Yeah,
should be iterator.
great, that's the problem. Okay, great. We forgot to rename this. Okay? So thank you. You're up. Okay, if I come here, oops. Response is 32. Why? 32. Why? Because we're having here, what do we have here? We have 1 plus get data 10. Okay? 1 plus 10 equals what? Equals 11. Okay? Then plus 1, 12. Okay? Then we add 20. 20 plus 12 equal 32. This is why we are getting the response. Okay? This is a moment I would like to come here and just take the screen with me. Why? Because this is very important. Because we get to the point where we can write asynchronous code in synchronous fashion. And there is a guy called Kiel Simpson, I think. He's an American teacher. And he's well versed in asynchronous and all JavaScript related stuff. He said, good quote that I'm quoting from him. He said, once your brain stop working like a machine, at that time, bugs start to rise. It's a funny quote, but it's a real quote, okay? Now we have asynchronous code in synchronous fashion. We will reduce and we will eliminate a lot of bugs, okay? This is what's called async wait. Okay? This is async wait. Okay. Great. Now I have also 2 points, and I'm letting you, I let you go. I have another 2 points. We have also CSP, okay, this CSP, which is communicating sequential processes, which means there is different processes messaging between them, okay, sending and receiving messages, okay. There is also a concept that we call back pressure, okay, but you can find Google about it in the internet and you will find it. We have also this last, okay, observables, okay. This CSP is used heavily in the Go language and closure script, okay. This CSP is the model for asynchronous and concurrency code in the Go language, okay. And it's very powerful model, okay. We have CSP and observables. We have also here some resources if you want to learn more. We have this good resource by Gerify, the Kelly Simpson. It's very popular series of book. You don't know JavaScript, where he tackles all the problem or all the concepts or aspects of JavaScript. We have also this Google post about promises, okay, which is a good and useful article. We have also here generators. To read more about generators, we have also generators here. We have here also a video or YouTube video about observables and RxJS, which is what we call reactive programming, okay, which is a cool new feature, new concepts. We have also here a series of videos introducing to observables. I think it's free. It's a free series from the egghead.io, so you can download it and use it at home. We have also this thread, which is very rich about reactive programming. And we have also the library developed by Gerify called Asynchronous, which is pretty much this async library contains all the solutions, the callback solution, the thank solution, the promises, the generators, the observables, and the CSP, okay? So in this library, you will find all the models implemented in this library. And there is a lot of libraries, but this is one of the libraries created by this guy, okay? The guy who wrote this book series, okay? So this is the resources. So we get to the final point. Is there any question? I'm seeing you like, it's like I'm telling a story. Or is there any question?
Can you tell me what Twitter?
Hi, Twitter. HAM. By the way, I'm not reachable in Facebook. I don't use Facebook. And I think you should too. It's a useless service. Okay? It's more harmful than useful. Okay? Why Twitter? Because in Twitter you find all the technology makers. The leaders in technology, you find them in Twitter. Okay? Publishing about articles and the new stuff. Okay? And I have also this is my email. Okay? If you would like to contact. Okay, great. Any questions? Questions? Can I ask you a question?